Hello and welcome to Built Environment Matters, a monthly podcast brought to you by Bryden, an international company of technologists, designers, architects, engineers and analysts working for a better built environment. Bryden believe in design to value, to cut carbon, drive efficiency, save time, make beautiful places and build a better future.
Hello, I'm Alison Zack-Collins and I'll be your host for this episode. I'm joined by Jaimie Johnston, Director and Head of Global Systems at Bryden. Jaimie was Bryden first employee when Mark Bryden and Martin Wood set up the practice back in 1995. He's now recognised as one of the leading thinkers on the future of industrialised construction. In addition to his role here, he's also the design lead for the Construction Innovation Hub, a body funded by the UK government whose aim is to transform construction. Hi Jaimie, thanks for being here. What are you going to talk about today?
Hello again. It's good to be back and talking about the next chapter in the discussion around platforms. So on the last episode, I talked about what we mean by platforms. So these are common components that can be configured in lots and lots of different ways to create a range of assets across sectors. And I talked about the work that's being done currently by both the private sector and the public sector to move this forward. So for this session, I'm going to be talking much more about the possible end state. So where do I think we're going with platforms and what do I think a very plausible possible future looks like? So everything I'm going to sort of outline here, I think is completely technically achievable if the industry decides that this is the direction we should be heading in. So I'm going to try and set out what I think that looks like. So all of the technologies and the initiatives I'm going to outline are all underpinned or predicated on this idea of standardized, repeatable components. So in addition to all the time, cost, safety, quality, sustainability benefits I talked about last time, this idea of converging on some common components also unlocks all of the things around digital, the true power of digital, around data, around manufacturing. So it's a sort of key aspect. So probably a good way to describe this is to talk through a project lifecycle, imagining what the process from design to assembly looks like in a near future state.
Excellent. Sounds fascinating. So starting at the beginning, what does that look like?
So starting with design, hopefully everyone's seen the work we've previously been doing on Prism and Seismic, which are building configurators for housing and schools, respectively. We've also been working with Highways England on an algorithmic computational design system called Rapid Engineering Model, and we've got a similar thing for Network Rail, for UK Rail. So that shows a kind of capability to use configurators or these early stage design tools, both in terms of buildings, but also in terms of linear infrastructure. So it's kind of showing that capability to work all the way from site level up to, very much greater scale geospatial sort of cross-country level. Where I think all that's going is eventually those apps will start to link up and start to talk to each other. So what we're demonstrating with Prism, for instance, is this ability to generate a design very quickly and then use simulation to optimize that design, to refine the design and get the best possible design solution for a specific site. Where I think this will head is that all of those apps will start to form a linked digital ecosystem, and everything from the routing and placement of our linear infrastructure, so road, rail, hyperloops, the placement of major functions, whether it's commercial, education, residential, industrial, all of those kind of broad master planning things will be done not by people subjectively, but as a result of millions of iterations of potential placements optimized to create the best possible placement of all of these features. So I think rather than design things from scratch, more and more work at that scale will be done algorithmically. And what we're seeing with REM, for instance, is that if the algorithm creates an unusual outcome in the model, we don't fix the model. We go in and fix the rule set, which means the rules only get better, the algorithm only gets better, and over time it just creates better and better results. And what we're also starting to see is that while we have the ability now in RAID, for instance, to use lots of different data layers and optimize for lots of different things, that capability is going to grow. So what we're able to do is consider and optimize for many, many, many more aspects than people can possibly do, much better and much more consistently. The result of that will be that we'll have better considered, better placed infrastructure. The placement of all the major functions will be much more refined. And then at site level, we're already seeing with things like Prism, the fact that we can do endless simulation. So again, I think at site level, we'll use that capability to test endless different possible solutions on a site. We'll consider energy balance, people movements, overshadowing, architectural aesthetics and placemaking. And at site level, we'll get much better, much more considered designs. The result of all of that, I think, will actually be a better designed, built infrastructure. So one of the pushbacks we sometimes hear around modern methods of construction is that it will be the death of good design. It will mean cookie cutter buildings. I actually think the result will be we'll have much, much better designed, much more holistically designed and much more individual assets. And one of the key things about platforms has always been that we standardize at component level, but allow complete freedom at asset level. And I think we'll start to see a better quality built infrastructure. And we're already seeing our creative technologies team would say that the developing the algorithm, developing the computational design, that's as much a creative part of the process as sketching something. So I think we'll start to see a shift in where we think creativity is best placed.
How will this affect the rest of the process? Can you tell us what this looks like in terms of things like procurement, payment, and also what happens on site and once the building is in use?
In terms of procurement and payments, we've seen through the like of our Prism to platforms workflow, the fact that we can, as soon as we have a design that we like, we can instantly generate the data model and therefore the BIM model and all of the bill of materials and quantities and things. Where I think that will head is that as quickly as you can generate the model, that data set will be talking to the market and instantly telling you what the price is and the availability of all those components. So there's a company in the United States called Xometry with an X, and it's used by major manufacturers. And if you're developing a product for which you need components, you can upload the digital files of individual components. Xometry sends those out to its distributed network of pre-qualified manufacturers all over the United States, gets you a price. Once you're happy with it, those people make the components, bring them together, and you're tapping into this enormous network of individual specialists brought together through a single platform. So I think we'll see the like of that as we start to get into this platform space. So the Construction Innovation Hub, which is a UK government-backed initiative, it's been funded to drive innovation into the construction sector, is doing an awful lot of work on bringing some of the manufacturing expertise into construction. So things like advanced production quality planning, which is how manufacturing gets that consistency of products, how it tracks the quality of components. We're starting to see those sorts of things coming into construction now. So you can imagine a future where a vast distributed network of little suppliers all over the UK or globally are pre-qualified to make platform components. They're publishing their capability, they're publishing their pipeline, and as you're developing your platform model, it's instantly talking to those, getting you a price. I suspect we will cost things or price things not just on pure capital cost, but also on the carbon footprint of the individual manufacturers, the level of money they put into R&D or training of staff welfare, etc. So I think we won't just go necessarily for the cheapest components. They'll all be cheap. We'll be looking for the value add from our manufacturers, and it'll start to change how we think about how we procure things. I could easily imagine a future where once those components have been procured, they'll be manufactured, they'll be brought to site by autonomous vehicles. The delivery will have been pre-coordinated with the site activities to ensure that components turn up just when you need them and while placing least stress on local infrastructure. So again, the joining up between the design phase, the procurement, and the delivery onto site will happen automatically, instantaneously, and payments will be instant. We won't have all the kind of delays in payment, etc. So I think the procurement process will suddenly become something more akin to Amazon than it is the current sort of lengthy process. Once those components arrive on site, you've probably seen from videos we've been doing, we've already been testing what level of automation is appropriate on site. Through our work with Landsec, for instance, and Easy Space, we've also been looking at what level of automation is appropriate at component level, so laser cutting of components, and then use of reach stackers and like to place components. Again, I think that's going to start to become more and more enhanced as we go. So Bryden Wood has actually got a initiative called the Framework for Robotics and Automated Construction, where we're looking specifically at what levels of automation are appropriate and how do we start to design towards automation, or if we're going to use automation, what would that mean to the design of individual components. So I think we'll see more and more of where we're currently using reach stackers. I can imagine those being autonomous, lifting up the components, taking them to the point of use themselves. I don't think we'll get away with the need for people on site, but we'll have far fewer people. They'll be working much more safely, much more productively, and I suspect they'll be much more multi-skilled. So rather than thinking of themselves as having a particular trade, they will have been trained how to assemble a whole range of components. So one of the big shifts that came in automotive in terms of quality was they used to have people that were trained to do one task. They did that task all day, but if they saw a car moving down the line with the wing mirror hanging off, but they didn't do wing mirrors, they'd leave it. The big shift was they trained everyone how to do every single activity. So if you saw a wing mirror hanging off, you would know how to put the wing mirror on properly. The result they found was actually much, much better quality cars because everyone knew how to fix everything, but also much greater job satisfaction and productivity because suddenly people were doing a range of tasks rather than the same repetitive task. So I suspect we'll start to see multi-skilled gangs who know how to assemble all of these components and could build you a hospital one day, a school the next, a housing, a set of apartments the day after, again, using these standard components. Once we get into the in-use phase, I talked last time about this idea of assets starting to use IoT data and becoming more self-optimizing. I talked about this idea of loose-fit superstructures. So I'm not going to sort of labour that point again, but I think, again, one of the reasons this works in a platform space is that when we started, or when UK government started talking about the BIM mandate, some of the early slides that people have seen showed this idea of a feedback loop of data from operational assets feeding into the start of a design process, making better design decisions about what the need was and therefore driving the whole process digitally. That hasn't happened partly because people are unable to capture the operational data in quite the right format, and partly because there's a sort of missing digital gap at the start of the process that there's nothing for it to feed back into. I also think that's exacerbated by the fact that because in traditional construction, every building is a prototype, even if you had some sensible operational data, it only tells you about that asset type. It doesn't tell you anything about the next building you build, which is also a prototype. So again, I think the thing that platforms unlocks is that consistency of components, consistency of build means that you suddenly have something meaningful you could do with operational data. So it would tell you something around configuration of components, how the components perform, how the facade system is working, which would help you then refine the components and help you make a better asset next time. So again, I think that consistency of components and standardization gives you the ability then to start to properly put that feedback loop in place. And there's lots of talk around machine learning and artificial intelligence in construction. That requires a vast data set to train machine learning and AI. Again, if it's in its current chaotic form where every building is a prototype and the data is very unstructured, that's very, very hard to achieve. If you lived in a world where the design workflow, things like Prism to platforms, was completely digital, if you lived in a place where the procurement, the assembly was very digital, and there was a consistency at component level all the way through, suddenly it makes that feedback loop plausible. It makes the capture of data set plausible, and it's the thing I think that would potentially unlock application of machine learning and AI. So if we want to get into that space, we have to put in place the building blocks now. There's also a huge amount of talk about digital twins, which even the experts on this are saying, the digital twinning of built infrastructure is a long-term aspiration. Again, I think platforms is the thing that will accelerate it or start to meaningfully allow you to capture that level of data that you'd need to actually properly do digital twins.
And what happens when a building reaches the end of its life?
End of life, again, in the last talk, I talked a lot about the idea that at end of life, the platform components, you'd automatically have the provenance and you'd know what they could be used for, how they could be redeployed. So again, I think it's the thing that will properly allow us to get either into a circular economy, or the idea that you could take components from one asset and use them for a different asset type in a different part of the world is very appealing. The fact that we could start to redeploy things and reuse, obviously reduce, reuse, recycle. Reusing things is much more sustainable than recycling them even.
What kind of challenges and blockers are you currently facing?
So our experience has been that none of the challenges we're currently facing are technical. So of all the things I've mentioned, we're in the foothills of all of them, but we are developing these components, deploying automation, developing these workflows, looking differently at procurement. So I don't think there's any technical blockers. Everything that we're facing currently is the cultural mindset blockers. And a lot of the things we're discussing at the moment are around insurance, warranties, intellectual property, and risk allocation. So in my head, probably the thing that starts to unlock that is a proper discussion around risk, because it seems to crop up in an awful lot of the conversations we're having at the moment. So no one is suggesting that traditional construction isn't risky. We know from government departments when they've been capturing data on how much of their spend ends up in built asset value, a big chunk of it, nearly 10%, is risk allocation. So no one's suggesting construction isn't risky. It's a risk that's to some extent understood. I also think it's interesting that the risk profile in construction hasn't significantly dropped. In thousands of years of doing this, it's still about 10% risk pot. So it's not as though what we've currently been doing has fundamentally addressed the risk that surrounds each project. What I think platforms does is help to dramatically change that risk profile and reduce the overall amount of risk that's left. So, for instance, UK government is looking to, again, through the Construction Innovation Hub, it's looking to aggregate the demand across the different departments, harmonise the standards and requirements, develop the standard components. That, in my mind, creates a huge central body of knowledge, and it creates a library of common solutions, common components. So none of that work necessarily needs to be done from scratch on each project. If you then combine that with the digital tools that allow us to create better coordinated models, data-rich designs where we have program cost supply chain data embedded in the model, if you then combine that with the work that we're doing through the hub on advanced construction quality planning, surely that creates a much lower risk profile, because suddenly we're using standard components that have been developed. We've got much better data. We've got much better coordinated designs. The work that the hub's doing through APQP, getting that sort of consistency in the components, I think helps to address the sort of warranties and insurances question, for instance, because suddenly we have much greater provenance of our components. But all of that must mean that we have a dramatically different risk profile, which should then change to some extent the nature of the organisations or people's attitude toward risk. So in my head, the idea that we can use standard components, pre-prototype them, iron out all the problems. By the time we get to site, there should be very little left to learn. And certainly once you're out of the grounds, you should be doing standardised processes. I think that is the thing that would suddenly start to answer all these questions if people understood it properly. The other thing I think that change in risk profile should unlock is investment. So we know from talking to funders that construction is seen as by far the greatest risk of where they can place their money. Funders are nervy about placing too much big spend into construction because famously we deliver things, or our ability to deliver things to budget and on time is not fantastic. But we know there are vast sums of money available, and there's a lot of interest in financing clean technology, for instance. There's a lot of money going into the tech world. I think that one of the huge opportunities of platforms is if we demonstrated that we could consistently deliver things to price, to budget, investors would see construction very differently, and potentially we create a space where investing in infrastructure is seen as a very safe pair of hands. So the old adage, invest in bricks and mortar, I can see us creating a new version of that where investors start to flood towards construction because they can see it's got a healthy return. But also, as you invest in social infrastructure, it inevitably has a social benefit. It creates jobs, it creates skills. You need economic infrastructure to promote industry and things. So again, I think there's a potential for a virtuous circle where investors can see that construction infrastructure investment is a good bet. They can see that it has good returns. They can see that it has a bigger impact in society. And I would love to think that in the future, the pension funds, the clean tech investors, the venture capitalists will start thinking, actually, we should be pouring money into construction. It's seen as at least attractive a proposition as tech, for instance. What that should also mean is that we have more money for R&D. So again, construction's famously has a famously low investment in R&D. I'd love to think that if the money started coming in, we'd have much more money for R&D, which would allow us to test more of these ideas before going onto a site. So currently, for the Landsec project, for instance, we've prototyped everything on our facility down in Ropley before we've gone onto site. I love the idea that in the future we have R&D funding that anything we test has been tested endlessly before it gets anywhere near a live site. So automotive doesn't try a thing out and then put it into production. It tests it endlessly until it's absolutely certain how it performs, and only then does it deploy it. Again, construction, with every project being a prototype, there's very little opportunity normally to test something out before it has to go into a live project. I think if we could separate that out and we had R&D streams testing ideas, making them work completely perfectly before we deploy it in site. Again, all of this is just continuing to drop the risk profile and therefore continuing to make us more attractive, etc.
What role does government play in making this all happen?
So the government has got a crucial role to play in this, which I think they have been. It doesn't get talked about enough, but I think the evolution of an idea from UK government setting out the BIM mandate back in 2011 to start by 2016, or to be in full effect by 2016. By 2017, there was the autumn budget statement talking about government's going to use its spending power to drive modern method construction. Then they've put money into the Construction Innovation Hub, the UK Government Infrastructure Projects Authority, which for our international listeners sits between Cabinet Office and Treasury. So they develop the policies around infrastructure spend, and they, to some extent, hold the purse strings around infrastructure spend. So they've been pushing this platforms agenda. So I think there's a real consistency in what government's been saying. And over the last few years, they've continued to hold the same or broadcast the same message. They've put increasing levels of granularity around it. And yeah, I think it's fantastic. They've been sort of very, very straightforward in their approach, I guess, but also very consistent in their approach.
What impact has COVID-19 had on all of this?
Pre-COVID, we were on the flight path. From what I can see, the current situation with COVID has just accelerated this journey or accentuated the need to do it. So things like Project Speed are to some extent government talking to itself and saying, so our ability to get things done once the lockdown kicked off was extraordinary. So I use the example of the furlough website, the speed with which they developed the website, beta tested it, had it live and receiving thousands of applications. It happened in weeks, and it would have taken 3 years under a normal cycle of events. So I think part of Project Speed, the government saying, how do we keep that agility? How do we not lose that? How do we maintain our ability to get things to happen very quickly? And I think rather than develop a new plan post-COVID, they're looking at the current plan, which was develop platforms, get them across sector, and they're starting to say, right, how do I double down on that and make that happen quicker? So again, it should be sending a strong message to industry that this is likely to happen sooner rather than later, but it is going to happen. What we've seen in other sectors, so entertainment, music, retail, etc., that have been disrupted over the last 25 years, is that once these big shifts happen, lots of the big players have the opportunity, because they're in that market, to get ready for this, to shape themselves around this, and to start to really seize the benefits. So as I say, there's a vast global addressable market on the way. There's the right levers in place in terms of government support and policy. Certainly in the UK, it feels like all of the big players should be saying, right, this is going to happen. How do I shape myself for this? How do I get myself ready to address the market? And how do I see this as a massive benefit or an opportunity rather than something that should be resisted and blocked? What we're starting to see, certainly in the UK now, people forming an attitude to platforms and thinking about what it means for them.
So how do you feel about all of this becoming a reality? Are you optimistic?
Yes, I think as a person, I'm always very optimistic, but even as a realist, I think, one of the things that occurs to me is the construction industry has been saying for at least 30 years, why are we not like manufacturing? Why do we not make this shift? And a lot of the technologies we're talking about have been around for a long time. I think the thing that's changed this time is that, firstly, the challenges facing the industry around ageing demographic, productivity, impact of COVID, et cetera, have never been starker. They're very well documented, and I think everyone understands now the challenges. There's also the climate crisis, which again, construction is a vast contributor. Nearly 40% of carbon emissions are embodied carbon or carbon emissions from the built environment. So there's a sort of, very much widely recognised need to do this. There's the recognition of population growth on the horizon, but also we have all the enablers in place. So I think BIM was almost a sort of foundational piece of work that had to start. We had to get the hang of that level of digitalisation before we could move on to other things. And BIM was never an end state. It was always intended as an enabler of what followed. So I think that combination of desperate need to do it, wide recognition of the need to do it, and enablers in place is a set of circumstances we haven't had before. And it's surely the thing now that will allow people to move forward. Or the way I sometimes phrase it is, if you weren't going to do it now, what else were you waiting for? Like zombie apocalypse or something. I don't know. There's, if all the warning signs weren't there and all the enablers were not in place, what else would you need before you decided it was time to make a fundamental shift in construction? So, I'm very hopeful that the platform movement's gaining momentum. People are starting to engage with it more, and I'm really, really hopeful that all of the things I talked about the possible future, will be, our current reality in 5 years, 10 years time. Again, I think it's entirely achievable if the industry decides that this is a direction they want to go in. And if it's not, why not?
Thanks, Jaimie.
Okay, so that's it from me. Thanks again. Hopefully that was an interesting conversation, and I look forward to talking to you on the next one.
Next month, Jaimie will be joined by John Dyson. John is the former VP of Capital Strategy at GSK and now Professor of Human Enterprise at the University of Birmingham, UK. He and Jaimie will be talking about how we apply the principles of design to value to designing exceptionally complex process facilities, including pharmaceutical manufacturing, data centres, complex automated systems, and infrastructure. Make sure you don't miss out. Click the subscribe button. Until next month, thanks for joining us. Bye for now.
Thank you for listening to Built Environment Matters, a podcast brought to you by Bryden Wood. Listen and subscribe wherever you get your favourite podcast, and you can follow Bryden Wood on LinkedIn and Twitter.